The Sherman tank was not a sniper. It was a sledgehammer. Designed for mass production and reliable service, it was the backbone of the American armored forces. But on the battlefields of World War II, reliability was not enough. It was outgunned, outranged, and horrifically vulnerable. Its crews called it the Tommy Cooker. The Germans, with grim efficiency, called it the Ronson for the lighter that lit first time every time. A single hit from a German Panther or Tiger tank could turn a Sherman into a molten coffin in seconds. This is the story of how one man, a simple mechanic, looked at this sledgehammer and decided to turn it into a scalpel. How he used a forbidden trick to give the Sherman a fighting chance, and in doing so, saved countless lives. This is how the Sherman tank became a sniper. In the grim, muddy winter of 1944, the Allied advance had stalled. The war of movement across France had collapsed into a brutal, grinding attrition in the Hurtgen forest and the villages of the German border. Here, the Sherman's weaknesses were laid bare. Its 75mm main gun was virtually useless against the thick, sloped armor of the German big cats frontally. To have any chance of a kill, a Sherman crew had to execute a terrifying maneuver. Close the distance to near-suicidal ranges, often inside 300 yards, maneuver to the flank or rear, and fire. It was a duel where the American tank always fired second. The psychological toll was immense. Crews knew their steel chariot was also their potential funeral pyre. Every engagement was a gamble, with odds stacked brutally against them. The problem was simple, stark, and written in the charred hulls of burned-out Shermans. We cannot hit them before they hit us. The stakes could not be higher. The Battle of the Bulge was looming, a massive German offensive that would test the entire Allied line. Every tank, every crew was a precious asset. The failure to solve the Sherman's lethality crisis meant more dead boys, more lost battles, and a potentially protracted war. The High Command knew it. The new, more powerful 76mm gun was being rushed into production, but it wasn't enough. It was a better sledgehammer, but the Germans had a sharper one. The entire doctrine of American armored warfare was being questioned on the bloody fields of Europe. Something had to change. But change, especially unauthorized change, is a dangerous thing in the military. And that change would not come from a general, or a factory, or an official research program. It would come from a man who knew these machines better than he knew his own hands, a mechanic who saw the problem not on a map, but in the scarred metal and the tired, fearful eyes of the crews who came back from the line. He was about to break every rule in the book. The man staring into the guts of a battered M4 Sherman was Master Sergeant Karl Kettering. He wasn't a West Point officer. He wasn't a factory engineer from Detroit. He was a mechanic, a craftsman from the farmlands of Ohio, a man who believed that any machine, no matter how complex, could be understood and, more importantly, improved. Before the war, he'd kept the family tractor running with baling wire and ingenuity. Now, he was the wizard of the maintenance battalion, the man other mechanics came to with problems they couldn't solve. He knew the Sherman's every rattle, every oil leak, every quirk. He loved the tank for its reliability, but he was also painfully, personally aware of its fatal flaw. He had personally pulled the remains of friends from these steel boxes after they'd been torn open by 88mm shells. His workshop wasn't a clean laboratory. It was a muddy motor pool, smelling of grease, diesel, and cold despair. And it was here, surrounded by broken parts and the constant distant thunder of artillery, that the crazy idea began to form. The official solution was the new 76mm gun, but Kettering saw its limitations. It was better, but it didn't solve the fundamental problem of accuracy at extreme range. The Sherman's fire control was rudimentary. The gunner had a simple, telescopic sight, but making a long-range shot, especially against a small, weak point on a moving German tank, was largely a matter of luck and guesswork. It was like trying to thread a needle while riding a bicycle down a rocky hill. Kettering's forbidden idea was both absurdly simple and heretically complex. Take the technology from one weapon system and graft it onto another. His eyes fell upon the new M1 90mm anti-aircraft gun. This was a masterpiece of engineering, designed to lead and hit fast-moving aircraft at thousands of yards. And its secret weapon was the M7 gun director, a mechanical computer that calculated lead and range with breathtaking precision. Kettering's brain made the connection. If the 90mm could predict the path of a Stuka, why couldn't it predict the path of a Panzer? He took his idea to his commanding officer. The response was immediate and brutal. It was forbidden. The M7 director was classified technology, not to be tampered with. The Armored Corps had strict protocols. Tanks were built to specification, not modified in the field by sergeants. This was insubordination. This was a distraction. The logistics alone were a nightmare. Cannibalizing a critical anti-aircraft asset for a wild experiment? It was insane. The opposition wasn't just about rules, it was about doctrine, about the very identity of the American Army. American warfighting was about standardization and volume, not bespoke, field-expedient gadgets. Kettering was told in no uncertain terms to drop it, to focus on his job, keeping the tanks running, not redesigning them. He was ordered to forget his sniper scope. The war would be won by following the plan, not by a mechanic's reckless tinkering. But a man who has seen the cost of failure cannot simply forget. The order to stand down was like a spark in a fuel tank for Karl Kettering. The memory of those burned-out hulls was a ghost that followed him, a constant, silent reproach. In the dim light of his workshop, surrounded by the skeletons of broken tanks, he made his choice. He would defy the order. This wasn't about ambition, it was about survival, the survival of the boys he served alongside. He enlisted a small, trusted crew, a young electrical wizard from Brooklyn named Private Miller, and a cynical but brilliant fitter from Detroit, Corporal Jones. They worked in a secluded corner of the motor pool, under tarps and behind stacks of crates, their project hidden from prying eyes. They became ghosts, working long into the night, their only illumination a single bare bulb powered by a sputtering generator. This was their secret war, fought not against the Germans, but against the inertia of their own army. This is where we get into the nerd stuff, the beautiful, intricate mechanics of Kettering's vision. The M7 director wasn't a simple scope, it was a mechanical brain. It was a complex box of gears, cams, and optics, about the size of a small suitcase. The operator would input the target's estimated speed, altitude, and range using hand cranks. The M7 would then calculate the lead, where to aim to intercept the target, and transmit that data electronically to the guns, which would automatically train to the correct angle. Kettering's genius was in his adaptation. He and his team figured out how to bypass the anti-aircraft gun's motors and interface the director's output with the Sherman's turret traverse mechanism. It was a Frankenstein's monster of cabling and custom-fitted gears. Miller handled the electrical nightmares, splicing into the tank system without causing a short circuit that would give them away. Jones machined custom brackets and linkages with breathtaking precision, using salvage parts from wrecked vehicles. They weren't building a new tank, they were giving an old one a new nervous system. The first test was conducted in a rain-swept, abandoned quarry, far from the main base. The tension was palpable. They had mounted the M7 director on the Sherman's turret, a bizarre growth on the tank's familiar silhouette. Their target was a wrecked truck, positioned at what they estimated was 1,500 yards. Kettering, acting as the director operator, cranked in the data. Miller, inside the tank, watched as the turret began to swing, not under the gunner's hand, but under the command of the mechanical computer. It was working. The gun settled. They fired. The shell screamed downrange and missed, not by a little, but by a devastating margin, exploding harmlessly against the quarry wall far to the right. They tried again, and again. Each shot was a spectacular failure. The system was jerky, the turret movement was uneven, and the range estimation was hopelessly off. The M7 was designed for the vast, open sky, not for a target hiding in the folds of the earth. After a dozen wasted shells, their illicit ammunition spent, they sat in the mud, the cold rain soaking them to the bone. The silence was broken only by the hiss of the downpour. Jones, the cynic, voiced what they all felt. "It's a bust, Sarge. A beautiful, complicated bust." The dream of a sniper tank lay shattered in that muddy quarry, a monument to failure.
The aha moment didn't come in a flash of lightning, but in the grim, methodical process of elimination. Sitting in the leaking tent, poring over their failed test data, Kettering realized the core flaw. The M7 Director was designed for the clear, linear geometry of the sky, but on the ground, terrain was the great deceiver. Their initial range estimates were pure guesswork, and an error of just 50 yards at 1,000 meant a complete miss. They needed a way to know the exact distance to the target with scientific precision, and that key was found in an unlikely place, a damaged artillery observation post they were ordered to repair. There, Kettering laid his hands on a stereoscopic rangefinder. This was a device that used two lenses set apart like human eyes to calculate distance through triangulation. It was the missing piece. By integrating the rangefinder with the M7 Director, they could feed perfectly accurate range data into the mechanical computer. It was no longer guessing, it was calculating. They worked feverishly, modifying the cabling, creating a new workflow. The gunner would now use the rangefinder to get a precise distance. Kettering would input it into the M7, and the computer would command the turret. The mechanic from Ohio had built a system. The real test came not on a practice range, but in the shattered streets of a German border town. A week after their breakthrough, their unit was pinned down by a Panther tank dug in at the far end of the main street, over 1,800 yards away. It had already destroyed 2 Shermans that had tried to rush it. The company commander was desperate. It was then that Kettering, his heart hammering against his ribs, made his case. "Sir, let us try. We have a solution." With nothing to lose, the lieutenant agreed. Their modified Sherman, its strange new appendage looking more like a scientific instrument than a weapon, rumbled into a concealed firing position behind a shell-blasted building. The atmosphere inside the tank was thick with sweat and tension. This was no longer an experiment. Kettering, perched in his makeshift seat outside the turret, manned the rangefinder and director. He called out the data, his voice a steady monotone against the distant crump of artillery. "Target, Panther, range 1875 yards. He cranked the inputs. Inside, Miller watched as the turret began to traverse, smoothly this time, precisely. It was an eerie sight, the gun moving as if guided by an invisible hand. It settled. The gunner, his eye pressed to the normal sight, confirmed the crosshairs were dead on target. "On," he yelled. The loader slammed the breech shut. "Fire!" The tank rocked back. The shell was a blur across the urban canyon. Time seemed to freeze. Then a flash of orange and a jet of smoke erupted from the Panther's flank, right at the base of the turret. A perfect hit. A kill. There was no cheers, just a stunned silence, then a collective exhale of breath they didn't know they were holding. They had done it. They had just taken a shot that was previously considered impossible for a Sherman and made it look easy. The sledgehammer had just performed the work of a scalpel.
The impact was immediate and revolutionary. Word of the sniper Sherman's incredible kill spread through the battalion, then the regiment, like wildfire. Within days, Kettering and his team were no longer outcasts, they were miracle workers. The same high command that had forbidden the project now issued urgent, top-priority orders. Fit as many 76mm Shermans as possible with the modified M7 director and rangefinder system. Maintenance battalions were scrambled to replicate Kettering's field modification. The forbidden trick was now standard operating procedure. This wasn't just a new weapon, it was a new doctrine born from the bottom up. The Sherman, once forced to close to suicidal ranges, could now engage and destroy Panthers and Tigers from over 2,000 yards away, striking from positions of safety and concealment they never before possessed. It changed the calculus of every armored engagement in the final months of the war. The statistics bear out the legend. Unofficial reports from units equipped with the modified sniper Shermans showed a dramatic increase in first-round hit probability at extreme range, some estimates placing it as high as 80% compared to the near luck-based chances of the old system. They began to rack up kill ratios that were previously the sole domain of the Germans. More importantly, they saved lives. There is no way to calculate the number of crews who never had to make that deadly charge, the number of tanks that never became Tommy cookers because Karl Kettering saw a different way. For his actions, he was quietly awarded the Legion of Merit, not for valor in direct combat, but for his exceptional ingenuity and devotion to duty. It was a recognition that the war was won not just by men following orders, but by men who dared to think. The legacy of Master Sergeant Karl Kettering is not etched on a grand monument. It's found in the very principle of modern tank warfare. His desperate field modification was the direct ancestor of the advanced ballistic computers and laser rangefinders that guide every main battle tank today. He proved that innovation doesn't always come from a drawing board. Sometimes it comes from a grease-stained mechanic in a muddy motor pool, armed with nothing but genius and sheer will. He took a tool of war, the humble Sherman, and transformed it. He gave it a new eye, a new brain, and a new soul. That idea, born in defiance and forged in combat, became more than just a modification. It became a true war relic. What other forgotten innovations, what other acts of desperate brilliance changed the face of battle and then faded from history? Share your thoughts in the comments below and subscribe to the War Relic to uncover more stories of engineering against the odds.